properties of oxygen gas. It is colorless, odorless, and tasteless. That is 1. It has a low boiling point of -183 degrees Celsius. It is a neutral gas, neutral to litmus paper, so it has no effect on litmus paper, whether red or blue. Then it is slightly soluble in water. That is why it is collected over water. Chemical test for oxygen gas. Now, how do we test whether a given gas is oxygen gas? This is how we do it. We lower a glowing splint in a gas jar full of oxygen gas. The oxygen relights the glowing splint, and that one confirms that the gas is oxygen gas. If the glowing splint does not relight and form a flame, then that gas is not oxygen gas. Chemical properties of oxygen gas. Number 1, burning substances in air. Now, you find that metals and nonmetals burn in the presence of oxygen to form the corresponding oxides. For example, reaction of metals with oxygen and air. We look at burning magnesium. Magnesium burns in air with a bright white flame, forming a mixture of white and yellow solid. Now, the white solid is normally magnesium oxide, while the yellow solid is magnesium nitride. The equations for the reactions are as follows. Magnesium plus oxygen is magnesium oxide, while magnesium plus nitrogen forms magnesium nitride. When magnesium oxide is reacted with water, then it forms an alkaline solution of magnesium hydroxide. Same case, when magnesium nitride reacts with water, it forms a solution of magnesium hydroxide and ammonia gas. So these two solids are soluble in water to form the corresponding hydroxides, with magnesium nitride producing ammonia together with the magnesium hydroxide. Another reaction is burning of sodium. Sodium burns with a yellow flame in air, forming a white solid, which is sodium oxide. Sodium plus oxygen gives us sodium oxide. Now we need to understand that the only part of air that supports burning is the oxygen, and that's why we are saying burning in air. So it will burn in the oxygen, though some reactive metals burn also in nitrogen, like we have seen in the case of magnesium. So sodium plus oxygen is sodium oxide. Sodium plus oxygen to give us sodium oxide. Sodium is also a reactive metal which burns in nitrogen to form sodium nitride. Sodium oxide plus water is sodium hydroxide. And we need to note that sodium oxide reacts with water to form a basic solution of sodium hydroxide, which turns red litmus paper to blue. Sodium burns in pure oxygen to form a yellow solid called sodium peroxide. So sodium plus oxygen when it is pure to form sodium peroxide. Sodium peroxide dissolves in water to form a basic solution of sodium hydroxide. Burning of calcium. Let's see how calcium burns in air. Now, calcium burns in air with a red flame, forming a white solid which is calcium oxide. Calcium plus oxygen to form calcium oxide. Then calcium also burns in nitrogen because it's also a reactive metal to form calcium nitride. So calcium plus nitrogen to give us calcium nitride. Let us move on now to burning of iron. Iron does not really burn, but it glows red in the presence of oxygen, forming a few sparks, forming iron 3 oxide. Iron 3 oxide is insoluble in water, and hence it has no effect on red or blue litmus paper. Burning of copper. Copper burns in oxygen with a green flame, forming black copper 2 oxide. Copper plus oxygen to give us copper 2 oxide. Copper 2 oxide is insoluble in water, hence it has no effect on red or blue litmus papers. Elements burn in air and oxygen at different rates. They burn faster in oxygen than in air, because nitrogen slows down the rate of burning in air. So it is important to notice that among all these elements we have discussed and how they burn in air, they burn at different rates. But in pure oxygen, they burn faster than in air, because air contains nitrogen and the nitrogen slows down the burning process. Now let's look at reaction of nonmetals in oxygen, and we start with burning of sulfur. Sulfur is a nonmetal which burns with a blue flame to form sulfur 4 oxide. So sulfur plus oxygen gives us sulfur 4 oxide, and the sulfur 4 oxide reacts with water to form sulfuric 4 acid. Burning of phosphorus in air. Phosphorus is another nonmetal which burns in air with a white flame, forming a mixture of phosphorus 3 oxide and phosphorus 5 oxide. Now these two oxides dissolve in water to form acidic solutions. Phosphorus plus oxygen to give phosphorus 3 oxide. Then we have fossil phosphorus plus oxygen giving us phosphorus 5 oxide. Phosphorus 3 oxide plus water forms phosphoric 3 acid, while phosphorus 5 oxide plus water forms phosphoric 5 acid. Now then lastly we look at burning of carbon in air. Carbon burns in air with a yellow flame to form a mixture of oxides. 1. Carbon 2 oxide and carbon 4 oxide. So carbon plus oxygen, which is limited, then we form carbon 2 oxide. Then carbon plus oxygen, which is in excess, we form carbon 4 oxide. Carbon 4 oxide plus water forms a weak carbonic acid, which is a very weak acid. Now, I have said before that the reaction of metals with the air or oxygen varies from metal to metal, and from that we can be able to form a reactivity series of metals, with potassium being the most reactive metal, followed by sodium, calcium, magnesium, aluminium, carbon, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold is the least reactive. So depending on the position the metal is in the reactivity series, you can be able to tell how it's going to react with oxygen or air. So you can use the following acronym to be able to remember how the metals follow each other in the series. For example, we have popular scientists can make a common zoo in low humid countryside where most students go. That one can really help you to remember how the metals follow each other in the reactivity series. Now that marks the end of our lesson for today. I hope you've enjoyed the lesson. Follow and subscribe for more interesting lessons in future. Bye.